Hello everyone, my name is Sam Biddlecom. I am the Motion Product Specialist here at EandM, and today I am going to do an expansion of a previous video I've done on this page where I had configured a single axis servo motor system of an S210 solution here on Selection Tool, and now expanding that into a multi-drive axis system with a shared infeed, as I had briefly mentioned in the video before. Defaulting when we choose a drive technologies and new devices, and starting off with this page to kind of break down and define our portfolio. Instead of leaving the single axis drive system here, we are going to be clicking on the multi-axis drive system with a shared infeed here, and when doing so, be prompted to choose which axes we want to include in this drive system. We can either have multiple already defined, or just, as I like to do it, stick with the one, and then once we choose the option of that axis and press accept, we will be then configured over to this whole system here with control electronics, DC link, and our singular axis, with the ability to add extra axes right here with this option in our project tree. Now that we've kind of defined and kind of broken down how we get from our single axis here to our multi-drive axis drive system shown here, as can be seen with this change on axis BC, for example, I'm just going to delete this random axis. Going back down to axis BC, both axis BC and BS are kind of set up similarly to how we've done before, so to save time, I won't dwell too much on these axes, but essentially it's like a copy and paste method. You define your load via the mechanical model and motion profile, and then choose a motor and a inverter, or in this case, a slim motor module from the S120 family, and then define your cabling. So our axis BS is a ball screw actuator for the mechanical model. This is very similar to what we did before. So I've defined my load here. I've chosen a 1FK7 motor and an S120 Slim Motor Module, and I have assigned a cable to it. But for focus today, I will focus on axis BC, where my load is now a belt conveyor. And I have configured it as such. We have a new graphic and the asterisk for the necessary specifications to configure to complete. Our mechanical model is our steady payload, as well as our diameter of the drive wheel that we have, diameter D here. So once I define those, I get the green check mark. Of course, you can add other options as needed if you have them calculated out, and also having these calculator options here to help calculate out your inertia and so on and so forth, as well as choosing what sort of geometry we're using. Pretty helpful tool. Same with our motion profile as we did before. I've added a few more stops in the motion profile as well to kind of help flesh it out, showing that you can just add multiple moves as needed, either in the reverse or forward direction, whatever you may need, and even define different options by moving these pins around if you would like. From there, I chose a 1FK7 motor as well, this time speccing and choosing to have the 1FK7 motor with some sort of gearbox attached to it, hence why we see the gearbox, the stages, and the gear ratio we have. Our ratio is a 28 with a 2-stage gearbox connected to the 1FK7 motor we have defined, which then connects to this slim motor module as well. Both green check marks, they're not conflicting with each other, we're looking good. Next, I went to our navigating of cables. As you can see, there is a difference from what we had in our previous video, where the S210 system utilizes a one cable connection, or OCC. We are now using an S120 system, which utilizes two cables separate for power, as defined in this 5-meter cable I've defined up here with this orange bar, and this dotted, undefined signal cable I have yet to configure. But we will be configuring that later on when we look at the control electronics above. So now that we have our axes defined and kind of broken those down, oh, and then one more thing I want to show as well here before we move on to our DC link tab is we have the dimensioning where I have chosen the motor here, but I've also decided to go into the configuring tab and here see other options for the motor that we can define, and I've actually changed the default of our encoder system from an incremental single turn encoder to an absolute encoder with multi-turn and 20-bit resolution Drive-CLiQ connection. Design of sensor shown below here. Now, we can head over to our DC link, where similarly to adding our motor and our inverter, as we have seen before, we just click on the add line module, which will then open up a similar page breaking down our application requirements, what each of the items are represented by, our rated power, maximum power, type of construction frame size, cooling method type, etc., and match the best available active line module to our application requirements. As you can see, very low power requirements here, so our first option, very little utilization, will be perfect for this. Double click to add, and as you can see, it is fully defined, green check mark in our project tree, and we are good. There is no errors coming up. We can also go into configure again, see if we want to change our EMC category and any sort of fuse switch disconnectors as well. But for now, we're going to go right into the DC-Link tab itself and further define some options. So here, when we click on DC-Link, we are brought to our DC-Link arrangement specifically. This is where we can have any sort of additional components like a braking module, and we can define those as such as a book size or book size compact. We can also enable mean braking, power check above, and then add some extra options if we do decide to have a braking module. None of our motors have a brake, so we don't have to worry about this for now, so I'll keep this limited. Our dimensioning specifications. This dimensions maximum available footprint in space in our enclosure. And then finally, our DC-Link components below shows each of our hardware components we have defined below in a nice line as if it was going to be mounted in the rack, showing our length and width dimensions here. So we have our two motor modules, our active line module, and the active interface module, which gets spec'd with our ALM to ensure it works as properly mentioned before. Next, after we have all this defined, I want to go over to this area, this tab, the 24-volt bus bar. This is where we're going to add our 24-volt terminal adapter bridges to each of the systems. As you can see, I think before when I was fiddling with this, already added one here just for use. You can either add these individually between each of the modules. In this case, our active line to access BS and access BS to access BC. And you can do that by either clicking and adding them individually or generate 24-volt standard arrangement as such here. You can see that our hazard symbol still appears. That can just be a little error in TIA selection tool, but as long as you have these adapter bridges across all of the components in the hardware selection here, you'll be fully defined and not have to worry about any sort of issues with your configuration. So essentially, by generating this 24-volt standard arrangement, we have completely defined this, even though we do have this hazard symbol saying we do not have enough of our configured bridges available. Ignoring this hazard symbol, we'll go right into our control unit, the CU320-2. When opening this up, we see our control unit and the needed compact flash card holding the drive software already added, but when we go into dimensioning, it opens up a little bit more. On the right of this side, we have our control unit configuration. Here we can choose our communication option, either Profinet or Profibus, the option board, see if we want to add any sort of expansions in the compact flash card, any sort of drive software functionality as well. And then as good practice on your control unit, you should have a BOP20 basic operator panel. This will be able to show you on the line any sort of alarms or alarm code showing if there's any faults or problems in the system, and be better able to track what's happening with your drives without having to connect into them via software or just while you're walking by. It's an operator panel. It's nice to show you that information. And then what we definitely have to do on the left here is we have to make sure we assign all of our components, so our slim motor modules and our active line module, to the control unit to be under its control. We can do this individually by checkmarking these boxes or just click Assign All. Once assigned, you just wait. You can see they're all assigned now. And now we can go into our Drive-CLiQ topology. Here we see our control unit, active line module, and slim motor modules here for each of the axes. And we can connect cables between all of the ports as needed, or similarly to our 24-volt bus bar designation, just click on Generate Standard Cabling. And voila, we have now connected our control unit to our active line module, which then is connected via daisy chain to each of our motor modules, and which then have the encoders connected to the motor as such. Below, we'll then see our Drive-CLiQ components, which will show from what port and from what starting point and the to point or the end point of where those cables are going. So, for example, this is our control unit via port X100, as can be seen here, is going to our S120 active line module, port X200, which is right here. And if you don't want to follow that, if you just highlight the row, as we've seen before, in purple, that cable is then defined in the topology above. And then from here, we can add and define the lengths to define the part numbers for each of our signal cables. Going with our CU320, our first one, do know that these are going to be in the cabinet, as we saw in our DC-Link components, as they're all kind of racked side by side as bookends, so to speak. So 1 meter is completely fine, and the minimum length is 1.2. So we can just click OK there. Do note and keep in mind that the axis for the motor modules to the motor encoder is the same distance as our power cable. So that was 5 meters, but as you can see, it is also defined as 5 meters here as well, which is perfect for our needs. So we'll just click OK. And we'll just use a basic cable. There should be options for extension as well if needed, but basic will suit our needs just fine for today's examples. Once we define that, we have defined everything in our control unit. We have all our cables done, and essentially we have just finished our multi-axis drive system with a shared in-feed system. We have our axes defined, we have our DC-Link and active line module defined, the bus bars added, we have our control unit defined, and our Drive-CLiQ topology. So now if you go into navigate cables, you'll still see this line that says we haven't defined it, even though we have. So we clicked on this info button, nothing there. But we have defined these as such in the control unit tabs itself and the Drive-CLiQ topology. So now when we go up to our order list, we can see it very nicely broken down in each group. So our group 1, our multi-axis drive system, we can see our control electronic elements. So we have our CU320 flash card, the BOB20, and the CU320 itself. Then we also have this motion connect, this 1.2 meter motion connect cable. But even though we defined in this area the signal cables for the encoder and the motor modules, we don't see them here. Perfectly okay, because those are defined below. As you can see here, here's our signal cable we defined underneath control electronics, connected to our motor module under axis BC, our power connection that was spec'd in our navigate cable section, and the motor itself for each of our axes. And then above, our active interface module and our active line module. And there you have it, all nicely broken down, and similarly can be exported and downloaded into a PDF or Excel file for your needs and for a full functioning BOM. Thank you very much for coming on this journey with me today as we spec'd this out. I hope to see you in the next one, and have a great rest of your day.